Welcome everybody. In this part of the video we will see how to start with a simple design of a box. For instance, it's always the first thing you start with a laser cutter, and then we move on to more complex things. So there are different ways to design a box or design anything with a laser cutter, but there are basic rules. So the first one is about the thickness. It's the fundamental aspect you have to keep in mind since the beginning of your design, and we'll see in a second why. And from that moment on, you can basically do whatever you want. Use different softwares, use different approach. For someone it's easier to design things in 2D, for someone it's easier to design things in 3D. Those two things gives you equal results. I will show you how to test pieces without having a laser cutter available next to you, and that's of course super useful. And that's basically it. So, the note I was saying about the thickness. Since the beginning you have to know exactly what's the thickness of the material, otherwise it's hard to get the proper match. And the proper match, as you can see here, is basically to have no extra material not in one side nor the other. So if I decide to use a 4mm plywood, this means that every line of these joints are going to be 4mm. If I get to something that it's a bit less than 4mm, it's hard to see on the camera, but here we have a tiny gap. And if I get to use more than 4mm, for that line I have extra materials, and this is easier to see. Of course, this problem happens the same way when I have a snap like this, or the other way around like that. Now, this is not necessarily a mistake. For instance, if you want to fill this with filler, or if you want to send paper away the dark line of a connection, you need extra material. So it could be a choice, but it must be something that you do because you know it and not, of course, by mistake. So that's it. Starting from this basic point of the proper thickness, we can move on and see how to do the design of the first object that, as we said, it's gonna be a box. Okay, I will use Rhino, but every CAD software that allows you to design in 2D is totally fine. Keep in mind, as we said, that because you need to know exactly the dimension of whatever you want to do, you really need to define that at the beginning and be precise about that. So the first basic exercise in a laser cutter lesson is to actually do a box. A box could be a very simple thing, but then we'll see how to evolve it into a more complex object. So we have two ways to design a box. The first one is to do it three-dimensionally, like the one I just did. The other one is to design the development of the box. So it's not exactly these kind of things, but it's basically an explosion of all the surfaces that you get from the box. So I can actually do this opening up all the pieces and snapping them together. So quickly. This kind of design is very common when you do packaging, for instance, but in general, if you're used to work in 2D, it's going to be pretty simple for you to do this without the help of a 3D file to start from. This is just to show you the complete process that I'm talking about. Okay, as you can see now we have flattened our box, and on this we can start to design. Now, having all the surfaces is a bit annoying to me, so I will just convert this into rectangles, taking away the surfaces. Now that we have our open box, we can start to design the things on the borders. So I just rotate it to have it in a more comfortable way, but the concept is exactly the same. At this point we can move to a top view, and it's gonna be easier to work from here. Now at this point we don't have any clue of the thickness as we were talking about before. This is because we haven't decided yet. So let's say it's going to be 4 millimeters, very common thickness in different materials, and we can start to design the thing. Now, when you design it from scratch, that is pretty unusual, the easier way is to design a module in which you decide, for instance, to have a connection every 20 millimeters or 15 millimeters. Now we get to define the thickness of the material. So this 4 millimeter segment that I just drew, this part here, is the one that actually defines all the connections. So here is the moment in which I decided it's going to be 4 millimeters. From this moment on, if I change thickness, I really have to redo a lot of things. So we said every 15 millimeters. So I go on. Okay, from this moment on, I could just, move forward and do the entire line, or I can stop the line here, use this as a module. To make things a bit more clear, I would move this line in the blue layer, so it's a bit more visible. And what you can do, and it's usually the easier way to go, is to copy this. Okay, at this point you got over the middle point. It's probably gonna be not particularly useful. I can select these two models, mirror them from the midpoint that it's actually there. Okay, this is very, very small. It makes no sense to have something like this. So what I'm gonna do is to take these two central modules, take away these two lines that are not needed, and close the thing with a single line. Okay. Okay. Now this is gonna be my basic line. I want to copy the first module outside. It's gonna be useful later. And with this line, I can actually take all the pieces. Okay, join them into a single line, and this is my first line I want to cut. Now, this is not just here. If we said that it's a good thing to have symmetrical pieces, that means that this line here is actually the same one we have here, and because the connection of this goes here as well, the line is the same one in this area here as well. And of course I can go on mirroring all the parts and taking these two, bringing it to the other box here. That is actually the same part. And last thing, take these two and copy them in the last box. Now, of course, the box, sorry, let's copy it again. Okay. I was saying, of course, a box is 6 pieces, but basically 3 of them repeated twice. At the beginning, it's good to get used to the logic of the thing, so I don't mind if you actually do a bit of extra work. That's gonna help you to get it stuck in your mind, and I think it's a good thing. Now, the next line, that is this one, I want this part, but it must go up. So just to make it easier, what I can do is to rotate this line 90 degrees, and the easier way is to start from this point. We will see in a second why to start from here. So as you noticed, the line that I'm drawing are always inside the rectangular shape that define the maximum size of that face. The thinner the material, the closer they get to the borders. The thicker, the more space I lose inside, and this is pretty obvious. So same concept here. I'm just copying this line here and here. Again, this part is probably not gonna be needed, so I can take it away. Let's select these two, mirror them. The middle point is here, those goes there, and then a final line to join these two. As before, let's keep a copy of this and select everything on this border here, plus the line that we drew at the end, join them together, and then the same thing as before. So we take the center point, we mirror it, we take this, we copy it, copy it, okay, mirror it again, copy it again, and then finally mirrored another time. Okay, here as well. So I can take actually these two lines being the same piece and copying them once more. Now, what you've seen here is a very long way to design a box, and we haven't yet get to the end yet. There are easy way, of course, but this is the best to understand what goes together with what. So at the beginning I would say do this, and then when you get better you can simplify the process, and I will show you a couple of ways to actually save a bit of time and work in this. So let's do the last thing. So we have our module here, we put it in this position, for instance. In this case it's going to be very short, so maybe it's enough to actually let's see, yeah, probably mirror it, definitely, and the extra line that we drew before. Okay, two pieces, the line here, let's join it. Good. So the temptation here would be to first mirror this, we finish this part, that sounds good, and then to actually rotate it like we did in high school in projections and technical drawing. Rotate it here and keep the line like this. Now this is definitely wrong. So if it goes outside of the border, it means that there's something that is not actually working properly. So whenever you draw something of your outside borders, that's a mistake. So you do that and then you move it in. This is actually showing you where these parts will go, and where this part will go, and where these parts will go. So now we know that this is the right one. Again, let's take the lines, mirror them, same here, then this again, let's mirror it here, oopsie, this line. Okay, now we have some extra lines here. This is not good. We don't want to have this because we want close profiles. So in a very rough way, what I'm gonna do is to pick up trim, cut away the extra borders that I definitely don't want. One here as well. Last two. Okay. Now we have the proper lines to cut, but we still have our rectangles on the back. So what I can do is to make a copy of all these lines here next to it. Okay, now these profiles are actually what I want to have. I can select one at a time, move them apart a bit just to see them better. Oops. Okay, join them, have a close profile. Now, because all the lines are already connected, I can select everything, including this little one here, join them and have closed profiles. 1, 2, 3, 4, 5, and 6. As we said, 2 of these are the same, this and this, this and this, and the 2 big one. Then again, this is the easier way to actually visualize what you're doing. Now, because of what we said, if we want to make an object bigger, we can't just take a piece and, scale it up. Because if we do this, this side here is not going to be 4 millimeters anymore. Actually, in this case, it is 6.84. So unless we are cutting on a piece of material with this specific dimension, that makes no sense. Okay, so last test, important thing to do. Not always you have your laser cutter with you. Actually, very few of you will probably have one at home, I hope. So there is a very simple, easy way to actually check that the thing works and that all the connection works out properly. And that's to select the pieces, extrude them into 4 millimeters, of course, pieces. And when you have these parts, and we can see better this way, we can move in our 3-dimensional view. I will select all these parts, move them in another layer, hide the rest. I would say it's going to be the easier way, and probably make this black. It's the most visible one. Okay, when you have these parts, you just have to assemble the thing. Okay, you have to rotate the pieces and snap them together to check that the connection actually works. So in Rhino you have a pretty nice way to do that. When you select the pieces, you get this thing here called gumball, and if you click, you get 90-degree rotation. In this case, it's going to be this way 90. In this case, it's going to be this way 90. Last one. Okay, so when we have all the pieces like that, I can select a corner that I see here and I see here. I click on that, it snaps, and I move the piece in position. As you see, it's super simple, very fast. You just have to pick up a point that you can see both in the piece you're handling, and the piece that is the target. Same thing here. Okay, now let's see if I got the right one. Seems so. And then again, this goes here. Okay, and let's close my object, putting the lid on top. Okay, so the box looks nice. It seems we actually managed to close everything the way it should be. So I would say it's a good result. That's it for the first video. The next one we'll see how to modify and get back the files. That's actually a pretty neat trick. Very useful when you have something complex assembled. A way to move back and forth between the 3D and 2D. And then how to design in a different way directly from 3D. It's a matter of taste. It's really up to you what you prefer. both way are gonna be good. So train on this. It's super simple. You don't need any machines to do that. But if the files fits in 3D here, you can be sure that you will have no problem.